In the second related rates problem, we have a tank of water in the shape of a cone, and it's leaking water at a constant rate of 2 cubic feet per hour, so pretty slowly. And we're trying to find at what rate is the depth of the water in the tank changing when the depth of the water is 6 feet. And then we're also trying to find at what rate is the radius of the top of the water changing when the depth of the water is 6 feet. All right, so this problem, let's go ahead and look at what we know and what we need to find. And it will depend on what part of the problem we're working on, of course. So the only thing we know is that the volume is equal to 1/3 pi r squared h. We know that the water is leaking out, so how can we say that mathematically? Well, we can say that we know that dv over dt is equal to -2, right? It's leaking out, so that means it's decreasing. The volume is decreasing at a rate of 2 feet cubed per hour. We want to find, so for the first problem, we want to find the rate at which the depth of the water is changing. And depth here is given by h. So we want to find dh over dt when the depth is 6 feet. So when h is 6. And then number 2, we want to find the rate at which the radius of the top of the water is changing. So we want to find that's given by r, so dr over dt when h equals 6. Okay, so in this case, I see two triangles that look alike. There's a larger triangle that represents the tank and a smaller triangle that represents the water. And so I'm thinking we'll need to use similar triangles. Okay, so these are things these are little clues that tell us what our relationship is. So we want to find a relationship between r and h. And why do we want to do that? Because you might be saying we already have a relationship. Well, when we have this formula up here, v equals 1/3 pi r squared h, notice we have 3 variables in that, and so that would be tough to deal with. So if we can get rid of one of those variables, that would be beneficial. So the relationship we're going to use is similar triangles, right? And so we know that r is to 5, so the radius of this tank is to the radius of this tank, as the height of that tank, so h, is to 14. And there are different ways to set those ratios up. So you may have set yours up differently. You may have said r is to h as 5 is to 14. That's also fine. So now in this first problem, we're trying to solve for find dh over dt. So we don't want the r in that problem at all if we can get rid of it, right? So how do we get rid of the r? Well, if we can write r in terms of h, that would be helpful. So I'm going to multiply both sides of the equation by 5 to get rid of the r. So multiply both sides by 5, I'm going to get r equals 5h over 14. Okay, so I'm going to take that r and I'm going to plug it in up here. And so for problem number 1, I'm going to have volume equals 1/3 pi, wherever there's an r, I'm going to plug in 5h over 14. And then we're going to square that and then times h. So what do I get? I get 1/3 pi, and then 25 h squared over 14 squared is 196, and then times h. I can write that a little more simply as 25 pi over 588 times h cubed. We have h squared times h, which is h cubed. So that's my volume formula. And now, if I can find the derivative, I can take the derivative of both sides with respect to t, then that will allow me to solve for dh over dt when h is 6. So taking the derivative of v, I get 1 dv over dt equals, now 25 pi over 588 is just a constant, so I can pull that out front. And then the derivative of h cubed is just 3h squared, and then remember we need dh over dt. All right, so what do we know? We know that dv over dt is -2, so I'm going to plug that in. And we're trying to figure out what dh over dt is when h is 6, so I'm also going to plug that in. And now I'm going to solve for dh over dt. So get your calculators out and attempt that. And what I get is -2 equals 14.426 times dh over dt. And then solving for dh over dt, I get -0.1386. And this is, again, we're working with feet per second, or feet per hour, so this is feet per hour. And so I want you to take a moment to think about what you just found. Okay, this is the rate at which the depth of the water is changing per hour, and it's changing at a rate of -0.1386 feet per hour. And it makes sense that it's a negative value because the depth is also going down as the water is leaking out. So for question number 2, we're trying to find the rate at which the radius of the top of the tank is, top of the water is changing. And so now instead of getting rid of the r, we want to get rid of the h so that we can have our r in there and find dr over dt. So again, let's go back up here to this, and instead of using this relationship, let's use, we're going to solve for h in terms of r. So I'm going to multiply both sides by 14. That would cancel that, and multiply by 14 here. So I get h is equal to 14r over 5. And then I'm going to plug that in for h into our volume equation. 1/3 pi r squared times 14 over 5r. Simplifying that, we get volume equals 14 pi over 15, 3 times 5 is 15, r cubed. All right, so from there, we can take the derivative, okay? So taking the derivative of the left side, we get 1 dv over dt equals the 14 pi over 15 can be pulled out, and then taking the derivative of r cubed is going to be 3r squared dr over dt. And so we want to plug in what we know. We know that dv over dt is -2, and then we have 14 pi over 15. And we know we're trying to solve for dr over dt. We don't know what r is, okay? So when h, it says find the rate at which the radius is changing when the depth of the water is 6. So we have to find out what r is. So let's go back up to this, this relationship. And we know that r over 5 is equal to h over 14. And we want to find out what r is when h is 6. So if we can plug in 6 for h, then we know that r is equal to 6 over 14 times 5. So r is going to be 30 over 14. And we're going to plug that in for r down here. So we have 3, and then we have 30 over 14, and we're going to square that, and then that's times dr over dt. So all we have left to do is to solve for dr over dt. You're going to use your order of operations and isolate dr over dt.